So a couple of years ago, I couldn't have imagined talking to you here about a Microsoft product, but persistence is futile is the thing that I've learned. When I was a teenager and in university, I was in love with Debian. I still like Linux a lot, but at some point I became compatible with the rest of the world and switched to Macintosh. But the business world is very much reliant on Microsoft, so that's how we ended up here. But Microsoft now also promised recently that they'll bring the Linux kernel to Windows 10, so they're finally seeing the light. When you talk about continuous delivery or DevOps, that raises expectations often, I have found, especially with senior leadership or management. They expect to compete with the Silicon Valley unicorns and do moonshots and do much more in much less time. That's a pretty high expectation to live up to. But, and that is what I want to tell you today, with a good tool, your brain, and some patience, I think you can get there even with a quite small team. And we did this both with a greenfield project that we are working on right now, digitizing some of our core business processes and also some of our legacy stuff. There's three key themes in this talk. The first one is how Azure DevOps as a service has been an enabler for us to grow a mature practice, despite us having a very small team. The second theme is really about how our journey has been pretty smooth during the growth, and how we have been able to evolve using the same tool. The third theme is about how we have been able to retrofit continuous integration and delivery to a legacy application. This is a traditional 90s architecture client database application. So before we dive into those, let me give you some context on our organization. The Swedish local government debt office, or Kommuninvest in Swedish, was founded in '86, so it's a bit over 30 years old. Then by 10 municipalities, and it's a membership bank, so we only give loans to our members. And currently we have 289 owners and members, and therefore also customers. The total number of municipalities and counties in Sweden is 310, so we have 21 potential customers left. So there are some that haven't seen the light yet. We're mid-size governmental lender for the small country that Sweden is, so we have a balance sheet last year of about 42 billion euros. There are some things that we're very proud of, and one of the things we're proud of is our work with green investment bonds. These are qualified investments where investors get to know that the investments will go to things that have an environmental impact. And Kommuninvest, despite our size, we were actually recognized by the UN Council for Climate Change for this work as one of 21 global award winners. So if you want to associate us with something, I would like you to associate us with that. Our CI/CD practice. So we had this greenfield project, and we knew we wanted to sort of set the precedent to give the good example, because we had the opportunity to do something entirely from scratch. And Azure DevOps really came about sort of accidentally. It wasn't really an active choice to go into that direction. But we had a TFS server on premises that sort of was moved up into the cloud. But it enabled for us very radical results in an otherwise very traditional IT environment. But let's first look at why would you want to do continuous delivery, in case you have missed that part. So for me, continuous delivery and DevOps is about generating throughput. In the 80s, Goldratt defined throughput for companies as the rate at which the company or the system generates money through sales. Looking at the DevOps handbook or the Phoenix project, I think we can define it for DevOps like this. Our throughput is the rate at which we generate value to deployments to production. So the challenge here is to create a consistent high flow of value into our production. So because there we can have an impact on our users, our customers, our internal users. And to generate that throughput, of course, we edit code, we push it into our repositories. Then we have to do builds and tests, and that is what continuous integration is about, right? Automating those aspects of your delivery pipeline. We have release management, the operations side of things, and there we automate that with continuous deployment into our various environments. So we have 4 environments for our new applications. So the throughput is really when we reach all the way through this chain into the production environment. That is what when we have the impact. So we want to minimize the time spent in that chain, right? From the developer making the change in the code to that value being delivered to the customer. Once you have automated a lot of those steps, you can start reducing your batch size, right? You can make smaller and smaller releases because now it's very cheap to do a release. You can just click it out, essentially. And smaller releases also carry less risk. There's much less code that has been changed. So doing the release is actually not such a big deal anymore. So Azure DevOps enabled this for us. Azure DevOps is a collection of services that you buy sort of in one go from Microsoft. It consists of 5 elements. This is a snapshot from the Microsoft website. There's no emphasis on the first item in the talk. The first one is Azure Boards. This is agile planning tools, your work item management, your Scrum boards, that sort of stuff. You can think of Jira as a competitor tool here. You have Azure Pipelines. So this is the actually automation tools, the stuff that you can build your continuous integration and continuous delivery scripts in. Then there is Azure Repos, which is sort of like TFS in the cloud. Microsoft was also enlightened. Now they support Git, not only team version control. Azure Test Plans, which is a suite of tools to help you in manual and exploratory testing. So this is not the automated bits. Those go into the pipelines. And then Artifacts, which is a package repository. So if you want to have a private Npm repository, for example, for your JavaScript packages, you can push those there and manage them there. We'll not talk about most of these today. We'll focus on the pipelines bit. How do we deliver stuff? Why did Azure DevOps work out for us? Right, I said it was an accidental choice. Communinvest in total has about 100 employees. So we're a pretty small organization. The blue part of the bar is everybody that's not working with IT or development at all, right? So these are all the financial people, the risk, the legal people. I have about 15 people that work with IT, and that is everybody, including me and the CIO, right? And the service desk person. We have a couple of developers on payroll, really only a handful. And then we rely a lot on contractors. So that is where most of our development capacity actually is. So we do not have, with these resources, the capability to establish something on-premise, right? You cannot maintain our own Jira and our own Confluence, and all these open source tools, they take an effort to run and operate. The other benefit for us with Azure DevOps was that these contractors that we bring in, they can actually bring their MSDN subscription benefits and they get a free license into the tool. So this was also for us a very cost-efficient way to get this capability. And to be honest, CI/CD is important for us, but it's not something that we can really differentiate ourselves with, right? But at the same time, a lot of our services are technology intensive now, the new ones. So that is why this ended up being a good fit. Looking at sort of the cost picture, I can be very open and honest here, right? We have about 21 users in the system. Last time I took a snapshot that are paid for, so that turns out to the tune of $118 a month. We have 36 stakeholder licenses. So these are free licenses that allow people to look at work items and wiki pages and that sort of stuff. So most of our staff they take a license here. We have the Visual Studio subscribers that I mentioned before, right? So these are the people that bring their MSDN subscription benefits with them. We buy a test plan to manage some of the manual testing. We buy some pipelines from Microsoft. So these are execution environments for your CI/CD workflows. And they are actually pretty cheap. They're $40 a piece. And you get an agent that can do builds for you 24/7. We have some support, there's an SLA, so in the end we pay $350 a month, which is really very, very cheap, right? I mean, we can hire a contractor for like 2 or 3 hours for that. But there's also some things hidden in this slide. The per user pricing actually goes up. The first couple of users are free. The next ones cost $6 a piece. The ones after that cost $8 a piece. I'm not sure whether the curve keeps increasing, but it's certainly an interesting way of Microsoft to price this product. The stakeholder licenses that our business people use, they're rather limited. They cannot add cards to Scrum boards. So the overall UX of that is pretty poor. They cannot edit wiki pages and contribute to those. So there's some limitations there. And the SLA is 3 nines, right? So that in theory is pretty good, but in practice we have had relatively frequent outages during office hours. So that has been hurting us a little bit. I would say like once every other month or so, we have a couple of hours that we have had issues. So there is not all greens. But without the simplicity of having this single tool, we would not have been able to achieve this. Now we can release during office hours without feeling something in our stomach like, oh, this is going to hurt. We take comfort in being able to release or roll back very quickly when something does go wrong and do that automatically. We do 1 to 2 releases a week now. And that is mostly limited now by architecture dependencies and that sort of stuff. It's no longer limited by, oh, we do not want to release. Right? We have actually the organization pushing us back, like, do not release this often. We do not understand what is going on anymore. And we have established a world-class practice. 2 years ago, I went to Microsoft's Tech Summit, and I listened to their VPs and architects on how you should use this tool. And I was hoping to learn stuff there. And I was like, yeah, but we already do this. And then I sent some of my developers to Ignite in Stockholm this year, and they came back with the same message. So my message to you is that this is not really very hard, right? If you're a couple of people and you have a brain, you can actually do this. So this is within reach with this tool. So we, of course, didn't start out with having achieved all of this. There was actually a growth. And I want to delve a little bit deeper into that growth and how it worked with our serverless applications in that, and what decisions we took along the way, right? I do not want to talk about, we did this and we did that. No, but what were the decisions? What was their impact during that process? And also, where do we want to go next? Because we're certainly not done with this yet. When we started out to automate stuff, we had already built up a tiny thing. This is a real-time quotation system, so our customers see live prices on loans. It included 2 web front ends. It had a backend for front ends to shield those, 4 microservices underneath, and there was 4 integration microservices. And all of these were running on serverless services in Azure. So the web front ends were hosted as web apps. The microservices were hosted in functions, and the integrations were hosted in logic apps. And all of the storage needs were taken care of with Azure Storage, so like table storage and blob storage. Now, 1.5 years later into this journey, we have had 3 more or less full-time equivalent developers working on this. We have 3 complete user journeys, 5 web front ends to maintain, 9 microservices, 24 integrations, and 78 Azure resources. So this grew relatively quickly because our units are very small. And we have this complexity times 4 environments. And we are able to manage this with confidence. Still deliver hot fixes within less than half a day. So this is really a great thing. So our decisions, how did we get here? How did we make this up? When it comes to source code, The first thing we decided was to do trunk-based development. I'm not sure how mainstream that is, but this was really a key thing for us because we do not have broken builds or branches that are sort of in unknown state living around there. So that means we do not have this work that is in flight but not delivered yet. It also makes the configuration of the automation a lot easier by just having the master branch to deal with. But because I don't have the architecture fully up to speed yet, we are still sometimes waiting. Things keep waiting for dependencies, so we do have a little bit of a dependency issue. We chose Git over the Microsoft TFS, and it allowed us to choose different development tools than only the Microsoft tool suite, which is also useful, especially for other projects. But this is not native in Microsoft tools. That sometimes hurts a little bit. We choose, in the beginning, to use a multi-repo approach instead of a mono-repo, so we do not have all the code in one repo. And this was really due to a limitation in the pipelines. This is something that we deal with still. It makes it easier to navigate the code base. So we are consolidating some of this now because now there is better sort of support in the pipelines to only react on a particular part of your repository. Once we had sort of the code in Git, we could start creating our build specifications. So these are GUI based for us now. And this is just a list of tasks. So there is an entire library of tasks that you can click together. Here we instruct a Microsoft-hosted agent, right? So we do not run this build machine ourselves to install the correct version of Node based on what we are currently compatible with. Run npm tasks to compile or create those Node packages. Run the unit tests. Do the build and then publish the results of that build into a package. Once you have created one of these, then you can start copy-pasting the pipelines. The other thing you can do is create task groups. So there's, if you have a sequence of common tasks, you can group them together and then reuse the task group in different pipelines. So all our Node projects, for example, can use the same tasks in the same way. And then getting continuous integration is as easy as ticking a box on the right. That's it. Every time somebody pushes something to master, the build will run. When we do stuff on branches, we trigger manual builds. That works fine for us now. Notice that we also have scheduled builds, and that is to do with one of the details on this slide, which is the Npm Audit. So we actually scan continuously for vulnerabilities, and we found that once a week is sort of the rate that we can deal with at the moment. I learned in a previous talk before lunch we should do this more often, because there's only 3 days between known vulnerability and exploit. That is what we managed to deal with right now. Once we started deploying this stuff, we had started by clicking together stuff in the Azure portal. And then we FTP'd stuff into that. It's serverless, so there is really not that much configuration. But later we started using the ARM templates. ARM is for Azure Resource Manager. It's a JSON-based format where you can specify what sort of service do you want, what the configuration parameters do you want it to have. So this is an example, I think, from a virtual machine. So it has an admin password and that sort of stuff. So you can set all the parameters that you want to set in that template and store it alongside the source code. These templates you can also create by exporting them from previous existing configurations in Azure. So we had already created some stuff, so we just download the description of what we already had and push that into a continuous delivery pipeline configuration. So here we took on some strategic depth. We decided to continue with the GUI-based configuration. You notice I circled in yellow the YAML option, so we can actually create these files in YAML. So rather than having to click them together, you can also store the configuration of the pipeline together with the code, which is something that we want to move to. To set up this for our initial service collection took us about 2 weeks. And now that gives us the benefits that I mentioned previously. The serverless aspect of this is really very, I was reflecting on this when I looked at the presentation again yesterday. It's very not there, because you don't have to care about these things. We tell just Microsoft that we want to push this into an Azure App Service. And that sort of does all the job for us. Once we have specified the configuration in this ARM template, which is updated here in an Azure deployment, we do instrumentation for our measurement and watching. Here we do some replacement to adjust the configuration based on the environment. And then you just publish your code. So it's that relatively easy. I also want to emphasize that this is not Azure exclusive, so we're doing this entire thing in Azure. But there is tasks for Docker, there is tasks for AWS, Octopus, the app stores, and many others. This is just a small screenshot of what is available. There's an entire marketplace for plugins, and you can create your own as well. So that may be something of interest if you are in a larger organization. So the other key decision that we took, and I skipped over when I was on the previous slide, is we used a service that is called Azure Key Vault. This is a repository where you can store passwords, SSL certificates, and that sort of secrets that you do not want to be stored alongside your source code. So at the deploy time, we pull stuff from that Key Vault into our configuration. So it is not out there and exposed, and the developers do not have to have the secrets that are there in the the production environment. So what does that look like in total? The developers push stuff to Git, and that includes then the code, but also this configuration description in the Azure ARM template, and a parameter file to that. So these are the configuration-specific options. That triggers a build process, which is defined in the Azure DevOps portal. The tests are run, etc. That generates what is called in Azure DevOps an artifact. So this is a collection of these things. And together with the specification of the release pipeline, that makes a release. So these are sort of specific instances of a combination of a configuration of your continuous delivery pipeline and the artifacts, so the code or the binaries. Then the agent takes that, queries the key vault for the necessary secrets, and pushes that into the environment of choice. And so the artifacts here are really sort of a key component. So a lot of things revolve around that. Our next design decision was to use manual triggers. We're currently still sort of, I think, figuring out our agile practice. We run 2-week sprints in Scrum, but we're still tweaking our release batch size. I mean, how much do we want to release at one time? And that is not so much more a technical question, that is also really what do we manage organizationally. So the continuous delivery for us actually only goes into the development environment right now. And from that, we manually order releases into the other environments. You can also connect these based on results from test suites, based on results from monitoring tools, based also, and that is the little person figures here, approvals. So what is not on this slide, because it didn't really fit, is the production environment. There's an approval stage, so that I or the product owner have to approve, like, okay, we're okay pushing this to production now. There is a limitation in the tool. So you have an overview of your releases. So here we see 3 releases and where they are in the stages. So this is the currently deployed release set. So release 2.14 is running in our pre-production or staging environment and also our production environment. Release 2.24 is running in a test environment, and 2.25 is running in a dev environment. But this is then for one particular microservice, right? A deployable unit. There is no concept in the tool of an aggregate of those. So a service collection or an application or something like that. That is a downside for us. You also notice that our production release is almost 4 weeks old there. So we have built a little dashboard, which I call "Where's My Delivery?" Where we have an overview of clustered services to see, okay, which release is where. And this is something that we just purely go through. It looks not very intuitive, but it does its job. It was hacked together very quickly. But this is a tool that we had to add on to DevOps. So cool. This works in Azure with Azure services. That was a big surprise. Not so much. We would expect Microsoft stuff to work together. So what I also wanted to talk to you a little bit about something else that we did with a legacy application, which is a very different deployment environment, and show you whether that is more or less painful. So how many of you have a system at home that was very modern in the day that computers were still beige? The release process of that system probably looks a little bit like this, right? The development team makes something nice, new, and shiny, like purple, and then it throws it over the wall to the operations team. Here you go. And the operations team is like, oh, I have to work at night shift now, or I have to work during the weekend. And then we're going to do agile, so we're going to make even more deliveries to the ops team. Imagine how happy they're going to be. And I understand that. The operations team, their installation tools often look a little bit like this, right? They do not have such good support. And when they then come to this night shift or weekend shift, their job is mostly copying files, patching database schemas, running installers, and then praying that everything will work. But in reality, the morning after, it's not a development team that gets the angry users, right? So I understand it very much. And the rollback plan for these systems is often something like this. It's like, oh, we have this old version, and then we have a somewhat older version, and what was the version that was running in production last time? Again, I don't remember. So Azure DevOps has something that is called the Devops Agent, which is a little tool that you install behind your firewall. It communicates to Azure DevOps through HTTPS. So you don't have to open your firewall for Azure DevOps to come in and poke around. So it's in that sense a little bit more compatible with most IT organizations. It also updates itself. It downloads all the plugins and things that it needs based on the task that it collects from the pipeline. So it's really rather low maintenance in that sense. The other thing it can do, it can contact your Active Directory on-premise to get authorization to do certain things on targets. Targets can be, Docker clusters, they can be servers, they can be file shares. And the neat thing is that the agent is not only available for Windows, it's also available for Linux, Unix, Mac OS. So you can not only authenticate against Active Directory, but also LDAP and that sort of stuff. So it's really cool thing. So this is our beast. It's called KI Master Data. It's a very descriptive name. Contains a lot. It lived for 20 years. It continues to live, and it will continue to live. It is a little wrapper application which on start checks whether there's any new binary files on the network share, and if there are, then it will push them to the desktop client. Which also means that all these desktop clients, they use a shared database to sort of work with data. I warned you about 90s architecture, right? And to safeguard sort of this in a continuous delivery age, we have now built a version check. So the client actually checks that the version of the schema on the database is the one that it expects. So we do not screw up the database. And this is what our deployment pipeline looks like. Here for the UAT environment, so this is an acceptance test environment. We kill instances running because this is just a single desktop. We change this configuration file to have the right database connection strings and that sort of stuff. And then we do Active Directory authenticated file copy into the target machine. The variables that are used here, they're stored in another tab that I won't bother to show you. And there, right now, we also store the credentials for the Active Directory authentication. But those can be made secret, so you have to have a certain level of privilege in this system to see them. And then this is what it looks like. So we have now, we started with that beginning of this year. And development has continued on that system in accelerated pace now. We have been able to do 190 commits as of middle of last month. And had I still done this the old way, it would have taken me at least 15 minutes for each commit to deploy it and maybe advance it, right? So on average, not all the commits, of course, advance to production. On average, it would have taken me about 15 minutes each. So I'm not sure how quick you are with your mods, but that's about a week of work. And that is something that we have gotten rid of. And that enables us to do very small releases in this old system, right? Because this system is pretty fragile. It's an architecture that nobody really understands fully. So being able to do small steps with the system is really something that is insanely valuable. I promised to show a demo. I chickened out of that. I'll show you a video instead to make sure that it actually works. But it's of this system, right? So we're here at release 190. We did a hotfix on a branch of a certain issue. But this is not currently running in the test environment, which you see on the far right of the slide there, where the cursor is. So let's see how long it takes to deploy that to the test environment now. We click on the environment that we want to deploy to. We hit the big deploy button up there. We confirm that we want to deploy this. Sometimes you can put an authorization here as well. We go into the detailed view. We're waiting now for the agent that is sitting behind our firewall to pick up the job. It picks up the job, it downloads the artifact, so it downloads the binary files from the cloud service. It will try to kill now any running application instances in the test environment. It takes a little while. Changes the configuration file, replaces tokens, and then puts files into its final space. We're done, and we clocked in at 23 seconds. Compared to the USB drive or remoting into a machine scenario, this is unbeatable. And happens, again, for our master branches automatically. What we have found, or what I have found so far, is that you advance to different maturity stages when you do this, right? We have old IT that maybe doesn't even do version control. We have had, and still have those systems. This is your first step. Then you want to establish some sort of process that allows you to actually get value out of more frequent releases, so some sort of agile process. You want to establish continuous integration, so you actually have something to deploy. And then you can move on to continuous delivery. And there, DevOps has, or Azure DevOps, the product itself then, has allowed us to grow, right? We have been able to first configure stuff in GUIs, then we can move on to the YAML files. We have been able to start out by clicking together our serverless services in the Azure portal, and now we're using these JSON files for configuration. The other really big benefit for us with Azure DevOps is that by having a single tool, we don't have any integration issues, right? So we can trace a commit, or a release. We can see what commits are in that release and what issues are associated with that. So we have full traceability. So we can actually see, okay, well, now we want to push this out to production. What is actually following along in this release? The downside is that there is no reverse knowledge. I cannot go, unfortunately, yet. If Microsoft hears this, please build this. I cannot go into this issue 4887 and see which environment is this currently running in, this particular commit. I can only see from a release perspective what is following along, but not the other way around. So I want to summarize with that continuous delivery for us, and in my opinion, is really a practice. You won't get it right the first time. I don't think you'll ever be done. We're certainly not done yet, even though we have achieved some pretty impressive stuff, I think, with 3 people. You need both time and a lot of continuous improvement to get to many releases per day. The Azure DevOps has given us the training wheels that we needed to grow with this, and it continues to grow with us, this tool. So when you fall during this journey, you have to get back up and enjoy the journey. Also, you won't be able to celebrate your releases anymore, right? Remember those release parties? They'll become too frequent, so celebrate what you learn instead. Thank you.
We do have time for questions. Any questions? Yes, Paul. So what about the infrastructure for monitoring? Mm-hmm. How is it done? Any tool in particular?
Yeah, so we...
Runtime monitoring.
Yeah, let's see, there is a little thing hidden on a slide that I didn't speak about. You see where it is? Here. Wait, different window. There was stuff happening on my desktop that I had no idea was happening there. Here. No. Here. So here we add instrumentation during the build process. And that is then watched over by it's OMS workspace. It's another Azure service that gives us a runtime view of all the executions. So this is also insanely cheap for us to get an aggregate view of what is happening. So we can actually follow each transaction. So if a customer says like, but this didn't work out, we can actually go and see, customer used the browser, the request came, the JSON file went from one microservice to the other, but there it crashed, sort of. Yeah.
Tracing too.
Yeah, yeah. So I mean, you have to tag stuff for that, right? So we have started adding, especially in our logic apps, adding instrumentation, and for example, putting a identifier along with the monitored information, so you can actually search on that, like, okay, which quote did we have issues with? Find it more easily among all the noise.
And in the pipeline, did you guys discuss continuous delivery versus deployment? The reason I'm asking, in our organization, when we started doing actually microservices and continuous delivery at the same time, and containerization at the same time, we started off with continuous deployment. So that git push would kick off the pipeline, and that would take the new release all the way to production environment. And a year later, I mean, I think 2 years later, no team was doing that anymore. Was only would kick off the pipeline, and it would take the microservice all the way to stage, to pre-production, if you will. So did you guys discuss that? Would it go to production, when or not?
Yeah, so that's where this slide was about, right? So we have a continuous deployment into our dev environment. I'm not sure why we don't do it into our test environment, to be honest. One of the reasons is probably because we have these triggered builds that are on a schedule, right, to check for vulnerabilities, and we do not necessarily want to advance them into the chain because they're oftentimes nothing new is in that build, so it's just noise. So that is one of the discussions that we have, and one of the things that has stirred or guided that decision is really these scheduled builds that we have. We ran into an interesting limit last summer when almost everybody was out of the office. Azure actually has a limit of how often you can push a configuration into a particular resource group if you do not change it. So it says like, I cannot do this deployment. because you have already done 500 deployments to this environment. So you have to clean up old configurations then.
Any other questions? Okay, let's one more time thank Thijmen.